Today's lesson is one of those really exciting ones where you get to learn about imaginary numbers. Before we get into it, we need to identify some terms that you're going to be familiar with. First of all, a rational number. Anything that you can write as a fraction. So even if you have a repeating decimal like 0.3 repeating, that's rational. Or 0.327 with the 27 repeating is rational. An irrational number is a number with a decimal that does not repeat and it doesn't end like pi, or the square root of 3. Now, we've talked all year long about real numbers, and that's the set of all rational and all irrational numbers. And occasionally it comes up, is there a number that's not real? Well, kind of. Imaginary numbers. We use the letter I to represent the square root of -1. The reason that we do this is because it allows us to compute further when we end up with a negative number under the radical. A pure imaginary number is a number that you can write as some number times I, where b is any non-zero real number. So you can write it like I times the square root of 2, or like 5i. So some things that are important. I is the square root of -1. So if we square it, we end up with square root of -1 squared. Those cancel, and we are left with -1. And this is the big important part right here. If r is some positive real number, then what we can do, let's call r 25. So we say, okay, we're going to take the square root of -25. What that means is we're taking the square root of -1 times 25, which means that we're taking the square root of -1 times the square root of 25. Well, I know the square root of -1 is I, the square root of 25 is 5. So we write that 5i. Let's simplify a few of these. We have the square root of -32. So that's the square root of -1 times the square root of 32. Now we should know that 32 is 2 to the power of 5, or we could think of it as 16 times 2. So we've got square root of -1 times the square root of 16 times the square root of 2. Okay, I can deal with this. The square root of 16 is 4, square root of -1 is I, and the square root of 2 we just leave. When we combine imaginary numbers, we first want to pull out the I, and we want to simplify the radical. So 5 times the square root of -6 is 5i times the square root of 6. The square root of -24, we can make that work too. It ends up being 2i times the square root of 6. So now we can combine 5i and -2i, and we get 3i times the square root of 6. When we multiply, the first thing that we need to do is pull out the imaginary number. So the square root of -3 is I root 3. The square root of -27, we would start by calling it I times the square root of 27. I would simplify this further by making this I times the square root of 3, and 27 ends up being 3 times the square root of 3. So we end up getting some pretty nice things happening here. I times I, or I squared, times 3 times the square root of 3 squared. This becomes -1 times 3 times 3, which gives us negative 9. I want you to notice here that the rule where we multiply these two things under the radical and then take the square root will not apply if you've got two negatives under the radical. The first thing we have to do in order to solve these is make them imaginary. And once they're pure imaginary numbers, then we go through the process of simplifying. This is very important, and that is why it is written in red letters in your notes. You cannot simply multiply these two, get a positive number, and be done. You absolutely must represent them as imaginary numbers first. So moving on, we'll continue that process. Negative square root of 5, I can write as I root 5. The square root of negative 75 would be I times 5 times the square root of 3. This gives me I squared times 5 times the square root of 15. And that becomes negative 1 times 5 times the square root of 15. And eventually that gives us negative 5 square root of 15. The same rules will apply when you're dividing. You have to represent everything as an imaginary number first, then we can proceed. So 4 times the square root of negative 18. Well, that will be 4i times 3 root 2. How on earth did you get that, Mrs. Busselmeyer? Well, 18 is 9 times 2, and the square root of 9 is 3. The square root of negative 12, it's going to be I times 2 root 3. Nope, that is not the best way to write these things, but as I'm thinking through it, it's what I might do. I can simplify that to be 12i square root of 2 over 2i square root of 3. Now some of our algebra rules do apply here, like the i's cancel. And actually, the 2 will cancel, and this will become a 6. So I will end up with 6 root 2 over root 3. And we're done, right? No, we are not done. You still have to rationalize your denominator. So we can multiply by the square root of 3 over the square root of 3. And we will end up with 6 root 6 over 3. Again, we can cancel. And our final answer is 2 times the square root of 6. Just a couple more. And the next one, 15 times the square root of negative 32. 15 over, this becomes 4i times the square root of 2. What I want to do at this point is I want to take I out of the denominator. Mathematically, the way that you do that is you multiply by I over I, which gives you 15i over 4i squared, square root of 2. So you end up with negative I, I'm pulling this out completely, times 15 over 4 square root of 2. You can skip this step if you want to, but the reason that it becomes negative I out front is because you end up with I squared in the denominator, which is negative. So once you're here, you still have to rationalize your denominator. So I will rewrite this . Or it can be rewritten this way, negative 15 I root 2 over 8. last one we're actually going to solve. So we have this equation, 4x squared plus 25 is equal to negative 23. And we follow all of our basic rules of algebra, beginning by subtracting 25 from both sides. Divide by 4. And then as we take the square root of both sides, we find out that x is equal to plus or minus the square root of negative 12